And it's still red, it's still working, high, okay, good, awesome. All right, so these aren't like super complicated, but they're a little complicated, right? And so an example might be 3 parentheses, so this is example 1. 3 parentheses 4x minus 7 equals 20. Okay? That's not hard, right? The only difference is between this and what we did last night is what? What does it have? Distributive property, right? Do you guys do you know the distributive property? Do you know what that is? Where this, remember, parenthesis always means multiply, right? Parenthesis is always multiply. Therefore, this is 3 times this and this. So I have to do these little arcs to remind me. And so to get rid of my parentheses, I have to do the multiplication. So 3 times 4x is 12x minus 21 equals 20. Now what do I do? Now it's like last night. Yeah, I plus 21, plus 21. I've got 12x is equal to 41. Divide by 12, easy, right? Piece of cake. X is equal to 41 twelfths. And I'm fine with leaving it like that. I do check to see, is there something that goes into both of them? Well, I think 41 is a prime number. What's a prime number again?
Their numbers are...
Isn't it like the only thing that its only factors or whatever are itself and 1?
Yes.
Exactly.
So 41 times 1 are that's the only way to get 41, right? But 12 is not a prime number. There's lots of possibilities. But since that's a prime, I can't go any further, right? So I just leave that as my answer, right? Put a circle around it or a box around it. They get harder when you see something like this. Here's another example. Let's say I had, let's see, do I have those in here? Oh yeah, okay. How about I have this? 2x minus 4 parenthesis 2x plus 3 equals 10. Okay, so the first thing I want to do is get rid of the parentheses, right? I can't solve this while there's parentheses. Don't try to do something here. Immediately we're going to do this times this times this. But what are we multiplying times this? Negative 4. You think of that. I know it says minus 4, but it's negative 4 is what you're multiplying, right? So negative 4, so I'm going to just rewrite my 2x. I'm not doing anything there. What's negative 4 times 2x? What? Negative 8x. What is negative 4 times 3? Negative 12 equals 10. Now what do I do?
You subtract 2x minus 8x.
Say what? So Luca.
You 2x minus 8x.
Okay, these are like terms, right? Those are like terms. Beautiful.
Oh, yeah.
So I can, because that's like 2 apples minus 8 apples, right? Because they both have the x in there, right? So I can combine those. What is that going to be? Negative 6x minus 12 equals 10. Now what would I do? Plus 12. Plus 12. So I've got negative 6 is equal to 22. Divide by negative 6, right? Negative 6. So x is equal to, and here, I know the negative is underneath, right? But I can put the negative here, I could put it here, or I could put it in front of the fraction. The typical rule of thumb is you don't usually leave it in the denominator. There's nothing wrong with it really, but usually you'll see the negative here or up here as your final answer. So I would probably just do this, negative 22/6. Oh my gosh, good thinking. What would I do it? How would it be?
11 thirds.
Okay, right? Divide that by 2, divide that by 2, negative 11 thirds. Beautiful. So that's my answer. Make sense? You get it, Naeem? Well, sometimes it'll work out beautifully. It might be, if it had been negative 12 thirds, it would have just been negative 4. You know what I mean? But if it doesn't simplify into a whole number, it's fine to leave it as a fraction. You don't have to go further. In algebra, often the fractions are more useful than other stuff. Okay,
This
where are we
is
doing?
kind of what we were doing in the class over there.
Over there? Yeah. Exactly. So that's why we've got that. Let me think. Sometimes you'll see, let me see if I can think of another one. What if I had this? 5 minus 2 parenthesis 2x plus 6 plus 8x equals 8. What would I do?
Multiply it to negative 2 times.
Okay, I've got to do my little arcs here to remind myself. So I'm going to just rewrite the 5. And then negative 2 times 2x is negative 4x. Negative 2 times 6 is negative 12. Plus 8x equals 8. So now what would I do? Now I'm going to show you what I would probably see half of the class doing, because this is what's been happening. A lot of people would do this. Oh, well, let's see. We want to get rid of they would do this. What's wrong with what I just did? How many people would have done that? Be honest. What would you, right? So what is wrong with it? So really I want you to learn from it. What's wrong with it? Yeah, look, the equal sign is here, right? This is where the rule says whatever you do to one side of an equation, you do to the other. What did we do? We added 8x to the left side of the equation. We added 4x and 4x, all to the left side of the equal sign. So we didn't add anything to this side, so we just destroyed the equation. It's no longer equal. Do you see what I mean? Because the rule of thought, the rule for algebra, it's the golden rule of algebra. Whatever you do to one side of an equal sign, you have to do to the other side of an
So
equal
would
sign.
you add 12?
So these are already on the same side. You can just combine them, right? Because there's a commutative property. You guys, do you know this? Do you remember this? Commutative property of algebra. And this property says you can move things around on the same side without doing anything particular. Like I could take this 8x and move it over here, and it's positive, right? So I could go 5 plus 8x minus 4x minus 12 equals 8. I didn't change anything, I just moved this over here, right? Boom, boom, and then these are all the same, right? You see what I mean? Because they're on the same side of the equal sign, all I have to do is combine them. That's it. So it's 8x minus 4x, or 8x minus 4x, that's just 4x. So I have 5 plus 4x minus 12 equals 8. Now what would I do? Look at this. These are like terms, negative 12 and positive 5. Right? Does this make sense? I don't want to go like this. I don't want to do this, negative 5, negative 5. Right? That's on the same side of the equal sign. Right? You see that? See that? You don't want to make that mistake. These are on the same side, so I just combine them. What is 5 minus 12? Negative what? 7? Okay, so we've got 4x minus 7 equals 8. Now what do I do? Add 7. So 4x equals 15. Divide by 4. I'm really good at finding all these that can't be, right? I'm making them up in my head. They don't solve evenly, but that's okay. Fractions are good. All right, so that fistify. Do you guys get these? I would expect most of you to get it. Is it making sense to you? Okay, good. And then the other kind of problem that you're going to see are are fractions. So what am I at? Number 4? Is that right? My examples? Is that right? If if I had 2/3 x plus 5/6 equals 4, I ask myself, I ask this, what is the lowest common denominator? Well, the first thing I'm asking is, what is the lowest common denominator? So I've got a 3 and a 6. What number do both of those numbers go into? Well, 6 doesn't go into 3. 6 goes into 18, 3 goes into 18. I could do that, but that's not the lowest. 6 doesn't go into 2. So this is what you do. This is what you do. You look at the, let me just think for a second. Look at the largest number. Look at the largest, so 12 is a possibility. It's still not the smallest. You look at the largest number, 6, and you ask yourself, can I turn this into the largest number? Can I multiply 3 times something? Oh, 6 is my lowest common denominator, right? Right? I could change it that way. So then you multiply everything by the lowest common denominator. Okay? So the lowest common denominator is 6. So I'm going to do this. When I multiply a fraction times a whole number, I'm multiplying it times the numerator. Times the numerator. And that's not a fraction, so I'll just multiply it times that. Okay? You with me? Now we start reducing. Do you guys all know how to upstairs, downstairs reduce?
Yes.
Before I actually, I could do 6 times 12, and that'd be 12/3. But it's easier in algebra to go like this. 3 goes into 3 once. 3 goes into 6 twice. Does everybody know what I'm doing? For sure?
Yeah.
Is there anybody that's lost? I'm dividing, I notice 3 goes into 6, so I'm saying 3 divided by 3 is 1. 6 divided by 3 is 2. And I'm crossing them out. So when I do that, then it's in simplest terms, right? So look what I'm going to have. I have now no fraction. This is the one move that gets rid of all your fractions. I have 4x. 2 times 2 is 4x. Plus, notice 6 goes 6. So Cassius, help me with this one. 6, they just cross out, right? 6 over 6 is 1, so I don't even need that. Plus 5 equals 24, right? Now it's really easy. You know how to do these, right? You just subtract 5, you've got 4x is equal to 19, right? And then divide by 4, x is equal to 19/4. Okay? Let's do one more, just to practice. Let's do it over here, 5. So let's say, see if I can find one that looks sort of, how about I do something like this? What if I gave you 1/4 x plus 2/5 equals 8/5. Okay? Now, I ask my question, what is the lowest common denominator? Because I want to get rid of my fractions in one move. This is the way I do it. What is my lowest common denominator? 4 goes into 5? So what is my lowest common denominator? I can see we need to practice the lowest common denominator thing, right? So 4 times 5 is always an option. That's 20, right? We could do that. I think that is it, right? That's the lowest common. In this case, that's the lowest. So I'm going to multiply the top times 20, the top times 20, the top times 20. And now I do my upstairs, downstairs reducing. So I notice 4 goes into 4 and 4 goes into 20. So I can say 4 divided by 4 is 1. 20 divided by 4 is what? 5, right? Okay, 5 goes into 20, so 5 divided by 5 is 1. 20 divided by 5 is 4, right? And this one's the same. 5 goes in 5 once, 5 goes in 24 times. Now, look, all my denominators are 1s, which means I don't even need them, right? Whenever you have 1 down below, I don't need it. So all I do is do 5 times 1 and then an x. So 5x plus 2 times 4, 8 equals 8 times 4, 32. Now it's easy, right? You know how to do these, right? See how easy? We took what a lot of people would use a very complicated method to solve. They'd probably get common denominators, and then they'd have these gigantic fractions, and then they'd be subtracting and adding, and then they'd be reducing and upstairs and downstairs and all this stuff. In one move, we just got rid of all our fractions, went from this mess to the easiest equation you can imagine, right? You get it? So that's it. And then you subtract 8, 5x is equal to 24, divide by 5, divide by 5, x is equal to 24 fifths. Beautiful. Yeah, I'm really good at this, aren't I? Sometimes I'm amazing at getting them right on, but these are not. Okay, so fist to 5. Do you guys understand? Is it clear? So it's just practice, right? For some of you, it's review. But isn't it helpful to go over this stuff again? I think, because you're going to need all this for, as things get more complicated, right? And 14th. Please tell me this is still working. Okay, good. All right.